Got it. Okay, welcome everybody. This is the August edition of the Developer User Group. I haven't done this for a while, so bear with me. Developer User Group is a non-profit organization. We meet monthly. The goal is just to learn and share with other people in the software development industry. It's really casual. It should be fun. And so we invite people to come and share if they've got something that's relevant to software developers. So tonight we've got VT, who's going to be talking about DynamoDB, and it's also got a serverless theme, which is quite exciting. So DevUG, sponsored by Tarsus On Demand, and thanks to Intellect for being our hosting partner tonight. We got some giveaways, so just as a, just going to hit up some announcements before we give VT the floor. We've got some tickets available to the TypeScript Origins movie premiere. This is Cape Town only, so if you are interested in going to that movie premiere, then just send an email to admin@developerug.org.za with the subject TypeScript Origins, and if you're the fastest to have done that, and if you've done that already, good on you. So we'll be giving away those tickets to the first two that sent that email through to us. We've also got tickets to Serverless Days in Cape Town. That's running later this year, October. It's running at Workshop 17, which is a flexible workspace and conference venue. And the call for speakers is also open. So if that's something that interests you, do submit a talk. It's a great way to get comfortable on stage and to prepare for whatever other talks that you might want to deliver at conferences. So 3 tickets to that to give away. So again, drop an email and then just put Serverless Days as your subject. First 3 emails received will win. There's another opportunity to win tonight. We've got JetBrains prizes, 3 of them. You'll have to stay until the end of VT's talk to find out how you can win those. If you've been with us before, you probably know how. And then there's another conference which I haven't mentioned on the slides because I don't want to steal the thunder. DataConf is coming to South Africa later this year. It's the first time that this event will be run, and I'd like to invite Mersha to share with us more about DataConf and how you might be able to participate. Mersha, not sure if you want to come on mic or Cam.
Yeah, I can do that. I haven't applied all my visual blurry effects here. Yes, we're hoping there will be good snacks. There will be lunch included. So cool. Yeah, so thanks, Candace. So DataConf is a new data conference. So the idea is it's just going to be a full day conference event focused on the topic of data. So kind of similar to DevConf, where you have a call for speakers and people can submit their talk proposals, and then we'll announce the agenda at some point after selecting speakers, and people can buy tickets and come and join the day. So the event will be held in Cape Town, the 25th of October. It focuses on data and is specifically not vendor specific. So it's not like a Microsoft shop or anything like that. And it's kind of across the whole data ecosystem. So data science, BI, data engineering, the whole spiel. So it's kind of generic and open to the community for the community. That's pretty much it.
That sounds exciting. Thank you. And so the call for speakers is open, right? And where can people go if they want to submit a talk?
I will post a link so you can find everything. Let me just not send it to you directly. So you can find everything on the main website. There is a convenient link to call for speakers and ticket sales on the main page. That's where you can go.
Fantastic. Thank you so much. So if anyone's got any questions, they can email, is it info@dataconf.co.za as well?
Yes, the contact is also on the homepage. There's some social media pages, but you can email that address as well.
Okay, wonderful. Thanks so much. Thanks for coming on and saying hello to everybody here tonight, and hope you enjoy the rest of the event. VT, so we welcome you tonight to present. I'm not sure if you've presented at the user group before. Is this your first time?
This is my first time.
Okay, fantastic.
Yes, excited. Thanks for the invite.
You're welcome. Thanks for being willing to come and share with us tonight. We've got a very friendly group of developers here in the audience. I'm sure they're going to be very interested in what you have to share. So without further ado, I will hand over to you and all the best.
Cool. Thank you. Share my screen now. Please let me know if you can see the screen.
I can.
Okay. Just going to move all this Zoom things out of the way. Hi, everyone. I'm VT. My full name is Vutlhari Rikhotso. Everyone, literally everyone, including my family, struggle pronouncing it. So I just go by VT. Again, sorry. Zoom is not my friend. About me, I'm a principal consultant at Daemon. A lot of people don't like the word consultant because it feels like we don't do anything, but really mostly still write code, but we focus on helping clients be able to kind of like do their own work. So we bring in expertise, document things, train people up. We're in and out type of organization, but technically I'm still really just a developer who's also a technical lead. I think that's the terms that we use mainly in SA. And I'm also 1/3 of the ZATechRadio podcast. I think now it's my responsibility to say that ZATechRadio is not at all associated with ZATech Slack. It was a long story, an accident, but it's a community that developed accidentally over COVID, and we have a podcast for it. You can find all that information on ZATechRadio.co.za. Cool. A bit of background. I think we all know, I think in the modern day, this is like the anatomy of an app. The expectation is that you have users need access to some sort of data, whether read and a write platform. So typically you put a load balancer and that's what your users hit. And then what would happen is that the load balancer would be routing your traffic to your app service, whether that it be virtual machines or whatever, however you choose to host your app. And then that data would typically be stored in a database. I think MySQL and Postgres are usually the default, but I think people are moving to all sorts of things now. MongoDB, if you're doing NoSQL, things like Cassandra, there's a lot of players in that space, so almost spoiled for choice. Excuse me. And then because our traditional relational databases are usually not very fast, or really for other reasons, we normally put a cache in front of that, mainly for your reads. So you'd have a distributed cache service, something like Redis, where if, for example, you frequently pull data, you'd be caching it there so users can access it a bit faster. Cool. So I hope everyone is familiar with the anatomy of an app. The focus of my talk today will be on the database to almost provide an alternative to the database choices that we usually make. But it will also kind of touch a bit on the caching. So we've spoken about the anatomy of a typical app. Let's talk more about a serverless app. I will reference mainly AWS because I am talking about DynamoDB, but this information is translatable to an alternative for DynamoDB. If for whatever reason you're not a big fan of AWS, is ScyllaDB, which really has very, very similar value proposition. So because we usually grab a relational database on AWS, people would grab for something like RDS. So you'd have your API gateway in the front, something like Lambda. Again, this talk is more serverless. And on the other end, you'd be using Amazon RDS to provision one of the popular relational database engines. So something like MySQL, Postgres, and if you're really unfortunate, Oracle. The problem that you run into here, you can run it doesn't have to be a serverless app. Even if you are running an app that has a lot of requests, is you run out of connections, right? So your performance degrades over time. There are solutions to this. AWS has AWS proxy. So instead of hitting the database directly, you can hit the proxy. But of course, this is something that you have to pay for. So typically, most people try to find a solution to this. Excuse me. And to understand that, I think we'd need to look at what our options or type of databases we usually have. So I think the most popular is your relational database. Again, Oracle, MariaDB, Postgres, MySQL, all of that. You have your analytical databases, something like Redshift or Teradata or things like that, where you usually store a lot of your data. You'd have key value stores, something like Memcached, or using something more like distributed cache, like a Redis for that. You'd have your document databases. So in that, you think MongoDB, or again, if you're more of an AWS fanboy like myself, that would be DocumentDB. And then we have DynamoDB, which kind of caters for both, but I'll cover that. And then you have like column family databases. You have graph databases if you're building a social network in the modern age. So these are the options that we have, but we'll almost always either grab the relational database, or with more, I guess if you've played around more on the NoSQL, you might grab like a document database like MongoDB. But I want to provide you with another option today, which is DynamoDB. So, but before we get to that, like, let's look at what are the main differences between like a relational or SQL database and NoSQL. By the way, just an interesting tidbit, every time I've seen on Twitter when I speak about NoSQL, everyone says, like gets very confused about why can you run SQL queries on some of these databases. Originally, when NoSQL came about, it was more about like not only SQL, that what the hashtag was about. So it was like these databases might have support for SQL-like queries, but they might have other alternatives as well. So the main differences between like a SQL-based database and a NoSQL-based database is that your SQL ones are likely to be very relational, which means that they have to scale vertically. So you can't really just add more computers. You usually add more computing power on the computer that you have, because the storage and the compute on your database engine is coupled together. Whereas when you start dealing with your NoSQL databases, they are more hierarchical. So the data storage is more flat, which allows you to almost, scale horizontally, which would mean instead of adding more computing power on your computer or storage on the computer, you can just add more computers. So typically with SQL, you're dealing with queries, where with NoSQL, you're dealing with instantiated views, right? So the main difference between these two, as I said, with SQL databases or relational databases, because of the coupling of storage and compute, you usually maximize on your storage, because again, databases is mainly about storage. So you see a lot of degradation when it comes to the compute power over time as your queries grow, or as you make more queries and you get more requests. Whereas with NoSQL, we maximize compute because it doesn't matter. We can just add more computers. So storage is not really as much of a concern as it would be on a relational database. And we'll get to why all of that matters now. So I've said all of that. What is DynamoDB? Well, prepare for a word salad. DynamoDB is a cloud-native, NoSQL, primarily key value database. So let's break down each one of those words. Cloud-native, it means that when the technology was built, it was built from the ground up to take advantage of cloud computing. So what does that mean? If you're looking at a place like AWS, because they've got an internal network, it means that if you're using one AWS service, you have the added benefit of being able to communicate directly with that database through the AWS network, which would be faster than if you're communicating it with it over the internet. But it also means that you don't, it's not really built for you to install anywhere else or manage it yourself. It's like fully managed for you. NoSQL, like I said, not only SQL in terms of how you actually interact with it. DynamoDB doesn't have SQL at all, and I might stand corrected. They release new things every day, so someone might have had a pot of a SQL-like interface over it. And then primarily key value. I say primarily because it's not only a key value store; it's also a document store. So the main difference between key value and document is that with a key value store, it might be like name VT, and that's it. Whereas if you're looking at a document, it's more like a tree. So there might be like different nodes kind of referencing each other. So think something like storing JSON documents in the database, which, by the way, you know, like databases like Postgres can do. So that's not like the only selling point. Cool. So a bit of history on DynamoDB. DynamoDB was built by AWS and is still today actively used by AWS. They published a paper that I would encourage everyone to read in 2007, the DynamoDB white paper. One of the authors of that paper is Amazon's current CTO. As I said, they've used this technology from day one, primarily on the Amazon shopping cart, because you can imagine everyone who's worked in retail knows the story of Black Friday. And they built this to solve those kind of problems. And today they don't struggle because of that. DynamoDB had reached general availability in 2012. So from then, all of us could use it. So it was battle tested within AWS way before they released it to the public. As I said, because it's cloud native, it's managed for you. It means that you don't have to do any hardware provisioning or even worry about how all of that is put together. They've got cross availability zone replication. So an availability zone is a physical data center where your data would be stored, or your compute machines might be running. So you can imagine if you're in South Africa, you might have an availability zone in Gauteng, one in the Western Cape, and another one in Durban, for example. So if your data is being stored in Gauteng and that availability zone goes down, it means that your data would have been replicated to one of the other two availability zones, meaning that you don't experience data loss. And this is not even something you enable. It's kind of just there for you by default. It also means that you get automatic monitoring and handling of failures. So things like failover, you don't have to worry about patches, updates, nor fixes. One of the reasons why it's a good shout for serverless projects, mostly people grab serverless projects, grab for serverless when they're working on side projects, because, well, if you're anything like me, you don't really want to pay anything. So it's not worth, having a VM running all the time. It's really, you're still experimenting. So this kind of falls nicely in that category because it's pay-per-use. The first 25 gigabytes stored per month is free. So like this is in total. So of course, like if you have less than 25 stored now this month, and then in the next month, you still have less than that, you're not paying anything. But if you start to exceed that data limit, you start paying for that. The price per gigabyte is just under 5 Rand. So really not very expensive. That's for storage. So you'll get billed for storage as well as compute. So with compute, this is your reads and your writes. Reading is much cheaper than writing because in most cases, like most applications will be read heavy anyway, not as write heavy. But for your writes, you pay just under 24 Rand per million request units. There is a way of calculating what your read request units and write request units might be if you have predictable workloads, but I think that's beyond the scope of this talk. And then again, you'll be paying just under 5 Rand for read request units per million. The scaling is down automatically for you because it scales horizontally and it's not something that you have to worry about. So DynamoDB automatically partitions your data, and we'll get to how that partitioning works. And each partition is completely independent. That's why you might basically be writing to computer 1 with some of your data and computer 2 or computer 20 with another, and there are no limits on workloads. I mean, this can kind of basically scale infinitely. At least there hasn't been any reports of someone hitting some sort of limit to date. With performance, one of the main selling points of DynamoDB is the promise of single-digit millisecond latency. So it means that for the writing and the reading from DynamoDB part of your request, you still have very much of a budget, because typically if you are building an application that has to be very fast, you might be budgeting something between 200 to 300 milliseconds. And this is good with DynamoDB because it means out of that latency budget, you're only going to use up to 9 milliseconds. And this is consistent regardless of whether you have 10 items in your database versus when you have 1 million items. This is enabled by AWS using a custom SSD-based platform. So your performance is independent of your table size, as I mentioned, and there's no need for a working set to fit into memory. So this is not something that you have to kind of think about, where with a traditional relational database, you might have to consider that. So what are some of the use cases? Like I said, I like to build side projects that die on GitHub and never go anywhere. So rapidly prototyping ideas and just trying to test if something is feasible, very, very great for that. It's very good for high volume transaction requests. So as I mentioned, Black Friday with Amazon themselves, because of it being able to consistently have the same latency for your reads and your writes. And it's used by the Amazon shopping cart. It's used by Duolingo, not really sure to what extent. And it's also used by Netflix. So if you use it, you'll be in good company. But like everything else, not every use case will be good for DynamoDB. So just to give you a bit of a guide, some of the good use cases for DynamoDB is if you have simple key value queries. So imagine you're trying to store session data for your application. This is a very good thing, because then you'd have your user and then you have your session or whatever stored, or session key stored in there. So it's very good. If you have an application that has very high read or write, and your relational databases might start to struggle because of how frequently you're calling your database, this might be good for that. If you want consistently low latency, single-digit millisecond latency guarantee, and if you want no size throughput limits. Cool. So bad use cases, we mentioned in the beginning that you might be using things like Redshift for analytics purposes. So if you have complex queries and joins as you would in a traditional relational database, then DynamoDB is not really is not meant for that. If you wanting things like real-time analytics and queries, then that's not the app for it. I mean, that's not the software for it. So I think the two broad cases is that if you're doing like online transaction processing, then DynamoDB would be good. But if you're doing analytics, then it might not be a good fit for it. Cool. I hope everyone's still with me. It's so weird looking into my screen and just looking at people's names and not seeing faces. It feels like talking into the abyss. Cool. So for the structure of DynamoDB, you've got 6 available data types. You've got your Scala data types and your multi-value, which are really just an extension of the one on the left. So you can store strings, numbers, and binaries, and you can store the set variants of that. So your string set, your number set, and your binary set. So really simple to remember. Also much easier in terms of like the flexibility of it. You don't have to deal with way too many data types. Indexing. So the whole magic behind DynamoDB is how your data is indexed, allowing it to scale horizontally. So this is done by using primary keys. You can have a simple primary key, which would just be a partition key. So imagine if you've got a table of users, you would be storing maybe their email address or their user ID as the partition key. Or if you want something a bit more complex, because let's say you're storing data about music artists. So you might have like an artist who has multiple albums. So if you just have a simple partition key or a hash key, and you're using the artist's name, it means that you can't store them again for something else. Like if you want to store multiple albums, that's where you use more like a composite primary key, and that would be your partition key, or also known as a hash key, or your sort key, also known as a range key. Please don't ask me why they have two names for this. It's just accepted and they use them interchangeably. So as an example, what you might have is that if you have that composite primary key with a hash and a range key, imagine you've got an artist, they've got albums. So you've got Taylor Swift album Fearless, and then so artist would be the hash key, and the album would be the range key. So if you look at Kanye West, the 808s and Heartbreak, and My Beautiful Dark Twisted Fantasy would be the sort keys for the album, allowing you to store like that. So this is what a DynamoDB table looks like. You've got your table, you've got your items, and then you've got your attributes. Again, the most important part of the table being the partition key and the sort key, because the attributes themselves can be variable. So for every item that you're storing in your table, the schema can be defined per item. So if you look at this table here, we're storing the book, we're storing albums, and we're storing movies, and also storing some combination of an album and a specific track. So you do need like something consistent, the same value type. So the product ID being a number in this case, and then the type being a string in that case would be the sort key, and then the attributes themselves can differ. So it's not like every item has to have every attribute, as you'd have like almost like a required or non-nullable column in a relational database. The reason why this is important is because to allow for that flexibility in terms of scaling horizontally, DynamoDB requires you to know the primary key. So straight out of the bat, you have to know that the product that I'm looking for is product 1, right? Because if you don't know that, then DynamoDB doesn't necessarily have a way of fetching that data for you. We will explore indexing later, but just think of it every single time you need to know where your data is stored in order for you to retrieve it. And you do that by knowing what the partition or the primary key is. Cool. So as I mentioned, the partition key here, hash key, is uniquely identifies a single item, and it's so it's using an unordered hash index, and it allows table partitioning for scale. So again, that horizontal scaling that I've mentioned a million times now. And then you've got the sort key. So in the case of using the sort key, instead of one attribute, you now have two attributes to uniquely identify an item. So instead of just an email address for a user, it might be the artist's name and album, to be able to get information about that artist's album. So in that case, the items would be arranged by the sort key. So they would literally be ordered as they stored by that sort key. So you can use things like dates, timestamps, and all of that for sort keys, meaning that data that is very closely related would be stored together. And then that means that there are no limits on the number of items per the hash key that you use. So you can, as long as your combination of the sort key and the hash key are unique, then you're good to go. Cool. So I mentioned that you've got, it sounds like a very limited way of you being able to query your data, because you have to know the partition key. So to solve for this in terms of like increasing the number of access patterns that you can enable on DynamoDB, DynamoDB uses local secondary indexes and global secondary indexes. The local secondary index is your first kind of index that you should know. The biggest caveat here being that it can only be created when you create the table, meaning that if you think of adding a local secondary index down the line, you might need to recreate your table. What the local secondary index allows you to do is that you can have an alternate range key or a sort key. So we'll see what that looks like right now. So you have the same partition key, same hash key, but a different sort, different attribute for the sort key. And the local index only points to like a single partition key, right? So if you were to look at this example that doesn't make use of a local secondary index, so just a basic DynamoDB table, you might have a table where you have items where the hash key is the country and the sort key is the scientist. So if you want to get your items, you can say, fine, get me an item where the country is France and the scientist begins with Marie. So that would get that item with Marie Curie, meaning that you can now, from the item, extract the field, the year, and the topic. But let's say you wanted to basically still say, fine, I know that the country is France, but instead of that, I'm looking for something else. So I want the scientist that was born after a specific year. So this is where you'd be using a local secondary index to say, fine, I want my hash key to remain the same, but I want to be able to query the data using a different sort key. And in this case, it would be the year. So you might think, again, this sounds very limited because I still have to know the hash key, and that's when global secondary indexes come in. So that's an index across all the partitions as opposed to a single partition with an LSI. What a GSI allows you to do is to have an alternate partition key and an alternate sort key, right? So you can use composite sort keys for compounded indexes, but it's a bit beyond the scope of this talk. So again, if we look at a simple DynamoDB table, so this doesn't have a global secondary index, you might have an artist, AC/DC, Kanye West, and that being your hash key, and then having the song be your sort key, right? But imagine you wanted to change all of that. So instead of needing to know who the artist is, you know who the album is, right? So that's a different way of querying your data. So instead of querying for AC/DC, this time around, you say you query for Back in Black, and you can either have the same sort key. So in this case would be the song or a different one. So this allows you for a bit more flexibility around how you query your data. The advantage of this is that global secondary index can be added anytime. So when you come up with new ways of querying your data, this is when it becomes very good. It is worth noting though that they do cost a bit extra. So if you can get away with designing your data initially to be able to use either the table without the index or a local secondary index, I would prefer that. So only use a GSI in cases where it is the right tool for the job. Cool. So we've seen now what it looks like. How do you model the data, and how does it differ from traditional relational databases? Well, you kind of almost have to think about the entirety of your app before you actually start modeling the data with DynamoDB. So you have to think of the use case. You have to think about your access patterns, what kind of information you're trying to read and write, how that reading and writing is going to happen. As I said, you need to know what the hash key is if you're going to be reading some data. You have to think about query dimensions and how you want to aggregate your data. And I think the most important thing is to try and actually avoid the, like relational DB patterns when modeling data for DynamoDB. If you do venture into DynamoDB, I encourage you to look at single table design. It's a very bizarre way of modeling data initially when you think about it, but like after a while, it makes a bit more sense because it maximizes the benefits of how data is stored with DynamoDB. So let's think about if we are modeling a delivery service, the business model might be customers want some stuff and we get them some stuff, right? So that's what we're writing down initially before we even create our database. We think about how the application would work. So people would be adding goods to some sort of list, and then we drop off those goods when and where they are needed. So if you were to look at an entity model for that, you'd have a customer who would be placing an order. An order has items, so one or more. A vendor or business would be accepting basically like to provide those items, and then a driver would be delivering the items. This is a very narrowed down of what a relational approach might be, but you might look into like, okay, cool, items belong to a specific vendor, and a driver has deliveries, and those deliveries would contain items. So you start thinking about things like item ID in the delivery, but then items would belong to an order and customer would have an order, that type of thing. I think that's a typical relational database approach of modeling this. But like, as I said, with DynamoDB, you don't look at it that way. So you start at the table level. So you might have a customer table, or if you're using a single table design, then you might have just an application table. And in there, you'd be storing your customers, your drivers, your deliveries, and all things like that. And then you'd be thinking about your items. So you can think about your items as your rows. So customer one, customer two, and then you'd have the attributes. So in this case, if you look at it like customer one, the name would be Jane, email would be jane@gmail.com, but John, who's also stored in the same table, doesn't have an email, and you don't have to store that for them. So you almost every time think about the table, the items, and the attributes, and how things relate to each other. And what that allows you to do is to have a different anatomy to that app. So instead of having something like the RDS proxy in there, you can actually just hit the DynamoDB directly, still maintaining that single-digit millisecond latency. But I did say that outside of the databases, there's a bit of caching that this talk is about. And this is that part where DynamoDB comes coupled with something called DynamoDB Accelerator, or DAX, which you can just enable, and you don't have to change any code in your application. You benefit from that. DAX is a caching layer on top of DynamoDB. Like cache hits, cache misses, all of that is managed for you. And you get up to 10 times performance improvement. So moving you from milliseconds to microseconds, regardless of the size of your app. And that is me, and I'm happy to take questions. Hello, is anyone there?
So hi, VT.
Go for it.
Oh, hi, VT. I hope you're good, man.
Oh, good, thank you.
I'd let you know about the storage. Like, how does it work for a production company to just store clips, to just store videos and clips, and what's the fees to go around that?
Sorry, I didn't catch that properly.
Can I type it down? I think speaker.
Okay.
Feel free to type it out as well. There was a couple comments about DynamoDB in the chat. A lot of info and papers, lots of cool stuff. Evolt has a question. Sorry, hello?
Yeah, I think I also want to ask, I don't know, VT, have you ever had any like production level experiences with Dynamo or any other NoSQL databases?
Yeah,
Because
we've used DynamoDB like for very simplistic use cases though. So think about things like being able to store some sort of like state of an application. So if you're filling in a long form and we want you to be able to continue or something like that, we have used it. We've used it for things like session storage and things like login tries and those kind of use cases in production.
Oh, nice. And is it way cheaper than a SQL DB? But yeah, I did get.
Look, I think the saying it's cheaper, it will really depend on the use case. So this talk is more like a very entry level view into DynamoDB. If I become fortunate enough to be invited again, we can delve deeper into some of the pitfalls. So it can get very expensive if not modeled correctly in terms of how you access your data. So like you can't really have a blanket approach of saying that it's cheaper than a relational database, but it can be.
Cool. I think that kind of answers your question as well, Evolt, right? Cool. And then Leholonolo, I'm sorry if I butchered that. Hi, VT. I'd like to know about how a production company uses the database system for a production company to store videos and clips. Which database should be used and what's the fees around that? Do we get charged for read and write and the storage used as well or achieved?
Yeah, look, so if you're storing media, look, again, I'm very much biased towards AWS, but you can achieve like similar things in other clouds like Azure. So in AWS, you'd actually be storing the videos themselves. And you said videos and the videos and clips in like S3, right? S3 is a whole other different storage, but like S3 is object storage. So you wouldn't necessarily like store videos in DynamoDB. You'd store that in S3 and then store maybe metadata about that video and a link to that video or those clips in DynamoDB, right? The advantage that you get for something like that is that a technology like S3 is very cheap when it comes to like data storage. I've actually compared like blob storage on Azure and Amazon S3, and S3 is unbelievable. Wow. That word is, I don't know what's happening. It's very cheap. But the advantage that you get on it as well is remember I spoke in the beginning that when you have something cloud native, you get the advantage of being able to use the cloud natively. So internal like network access. So if you're reading data out of S3 via the internet, there's a egress fee, right? So you'll pay information for pulling that data out. But if you're communicating between like S3 and DynamoDB internally within Amazon, then you're not really getting charged for that, right? And then you also get like some really, really, really fancy things happening because S3 has events. So you can say if someone actually, if someone like adds a video onto S3, it will trigger an object added event on S3, and you can decide to write that into DynamoDB, right? So the key or the link to what that is together with other information about like who it is that uploaded But DynamoDB also has something called streams. So as information comes in, you can stream that somewhere else and call something else, like, go and like clear the cache on a CDN or something like that. So like when you start playing around in the cloud natively, especially with the serverless like tech, it like starts working well together. And that's where something like DynamoDB shines. I know that was a very long answer, and I struggled to pronounce believe.
So good. That's really cool. I saw a question from Craig, but I think you kind of answered it. Is it possible to use DynamoDB in production outside of the cloud, the AWS cloud, for example, on an air-gapped network or something?
No, you can't use DynamoDB, like it's proprietary technology, so it's just available via APIs on AWS. So you can call the DynamoDB APIs from outside AWS using things like your access keys or via something like API Gateway, but you can't deploy it outside of AWS, if that's what you're asking.
Oh, I have a question as well. How would you say this sort of ecosystem compares with something like Google's Firebase, which is also, I believe, has some NoSQL, it has some buckets, it has some lambdas?
Look, I think there's like a pros and cons list. So I've been burnt once by I don't know if people remember Pause from Facebook, which was like the OG mobile backend as a service. This is that is the grave where things like Firebase and Superbase are built on top of. Those like mobile backends as a service are very like useful because you don't really have to like set up the communication between things. You almost get it all out of the box, which is great. The difference here with using AWS is like you're kind of just given like Lego and you have to put it all together yourself. And it's either you're very experienced and you can put it together better than Google can generalize something like Firebase, or you can put it together very badly and it starts, you might want to have to abandon an account or two.
Cool. I see you have a helper in the chat.
Yes.
Sile has
Yeah,
been helping you.
That's the other third of ZATechRadio. So
Awesome. So yeah, there's a couple of questions being answered there. That's pretty cool. Is there any other questions for VT directly? What's next for the podcast?
We don't know. I think what's next for the podcast is for us to try and host it ourselves, and then have more conversations that are hopefully helpful for people, and playing around with the idea of having a technical podcast, which is a whole different ballgame. So where we can debate DynamoDB and Sila and all those kind of things.
Cool. As someone who also does, like, I'm the producer for my wife's podcast on murder mysteries and stuff. I know the struggles of finding something like getting some way to distribute it properly that's not going to cost you anything.
Yes.
Yeah. Cool.
I think we have stumbled upon that podcast, Josh.
Really?
Yeah. If it's the one I'm thinking of, I'll check in with you offline. It's a great one. If
I'll
it's
drop you a
not
link
the
on
one
that.
that's your wife's one, then I guess I'll be introducing you to one that she might like. Pretty cool. VT, thank you very much for coming on and sharing about DynamoDB. It really is a bit of a like a mind twist from a relational DB situation, which I think
Yes.
most of us have like, come to know and love over the years. So it's something to twist our brains a little bit, but certainly we can see that the benefits are there. I just want to pop my screen up one more time just to share with everybody, if they weren't here at the start of the call, that there are these prizes to be won. We have received some emails already for the TypeScript Origins and the Serverless days. But if you missed that, here are some opportunities to win. And then the JetBrains prizes we were going to give to you, VT, to give away. So would you like to select from your most engaging audience members who you want to give those to? We've got 3.
Is it all 3?
Yeah, you can give away all 3.
Can I remember who asked the question? I think Craig was very engaged.
Yeah.
So Craig, I think Craig was very engaged. I'd like to give one to Craig.
Okay, super, Craig. We will be sending you I'm going to send you a direct message just to get your email address.
Okay. I think we had a very long question from Vutlhari.
Yes.
Can give one as well. And
Okay.
then there's one more. I don't know how do I pronounce your name? With an EW?
Evolt.
Evolt.
You can't give Evolt prizes.
I imagined he's part of the crew, so I can't give him one. Okay, I'll give one to Sisha for helping out.
Thank you. I think that's a brilliant
comments.
idea. Sikle did a
Thank you.
fantastic job. Fantastic.
Nepotism, but
Okay.
sorry. Thanks.
Stunning. Okay, well, that's it from us tonight. Almost 7 o'clock. Thanks everybody so much for joining, and hope you all have a wonderful rest of your Tuesday night. Wednesday night, oh my goodness, middle of the week.
Thank you. Cheers, everyone.
Oh, we've got Lekronolo said, sorry, I've messed it up. Also won one recently, so somebody else, VT.
Okay. Someone else. I'm not seeing a lot of other names in.
Okay, first person to send me your
chat.
email address, we'll give you a JetBrains prize.
Thank you.
Easy peasy. Super. Thanks so much, everybody. And thank you, VT.
Cool. Cheers, everyone.
Good night.
Bye.
Thanks, everyone. So we have one email directly in the chat. Have you gotten direct messages from anyone else yet?